Welcome to Math Today. Here is our lesson for this session. It says learn to estimate the area of irregular figures and to find the area of rectangles and parallelograms. So yes, we are looking at finding the area of shapes. Go ahead and write this down along with today's date and page number so you have your notebook all organized. All right, here's your warm-up. Try to tell me what the perimeter of a square with side lengths of 15 is. I think you should be able to do that. And what is the perimeter of a rectangle with lengths 16 centimeters and 11 centimeters? Come back when you think you got the right answer. And here are the correct answers you should have had. I like to draw out a lot when I'm looking at shapes. It just helps my mind easily be able to understand what we're looking at. So the lengths of a square are all the same, as you know from learning in previous years. So 15 plus 15 plus 15 plus 15 gives you 60 for the perimeter of a square. And what's the perimeter of the rectangle? The long ones are 16, the long sides, and the short sides are 11. So all I got to do is add them up. So what I did is I did 16 plus 16. That gives you 32. And 11 and 11 gives you 22. And when you add them together, you get 54 centimeters. So the one thing you'll notice is I wrote P equals for perimeter equals. And then I also made sure I always labeled properly so we know what the numbers represent. That's going to be very important in this unit as we move forward, just as it was with the first two lessons. All right, so our first note that we're going to be writing down today is what area is. Now, I know you remember what perimeter is, which is the distance around the outside of a shape. But area has to deal with the entire surface that the shape covers. So area of a figure is the amount of surface it covers, and we always measure it in square units. So remember, that means whenever you write your answer for an area, let's say it's centimeters, you would write centimeters to the power of 2, because it's squared. If you did inches, it would be inches to the power of 2, or inches squared. Feet, feet squared, and so on. So make sure you have this written down in your notes before moving forward. All right, before we get into this lesson, I want to let you know that as we go through all these lessons, we're going to be continually getting formulas for how to solve these things. And those formulas are algorithms, or they're plug and chug methods that if you use that formula every single time, that equation every single time, you're going to get the result you're looking for. So as we move forward, I do want you to have a page in your notebook. I would suggest maybe in the back of your notebook by the resource pages you put together at the beginning of the year that just lists all the formulas. So when it comes to quizzes, tests, even your homework, you can just refer back to that list at any time depending on what we are working with. Now at this first example that we're going to be doing, there really is no formula for shapes that look like the ones you see. But what you have to do is you have to be able to break down all the parts into different types of sizes or shapes that we're looking at. So what you're going to be doing in this first one is example 1. And what we're looking at in example 1 is estimating the area of irregular figures. Sometimes you get shapes like this, real life shapes. So how do you find the area? Well, what you have to do is you have to look at all these parts as what they are. So the first count, and you do want to write this in your notebook, the first counting you're going to do are the full squares. So to make it easy, we looked at the coloring here of full squares, and we made it red. Now if you look, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 full squares. So there's at least 19 miles, and I know it's miles squared because that's what our little key shows. There's at least 19 miles, square miles here, but there's a lot more other shapes to look at. So once you've filled in all the full squares, the second thing you want to look for are the almost full squares. And the almost full squares are, remember, we're estimating. So if it's almost full, we can kind of count it like it's a full square. So these ones we did in blue so you could see. This one up here is almost full, so that brings us to 20. This one's almost full, that's 21. This is almost full, that's 22. This is almost full, up to 23, 24, 25, 26, 27, and 28. So as we're adding up, we're up to about 28 now. The third one we look for are half squares. And each of those will count as a half. And let's see what we have here. We did those in green. So I should probably change my color here to, let's do red. So we're at 28. Well, here's a half and here's a half. That's about 29. Here's a half and here's a half. That's about 30. So we're up to about 30 now. And then we have all these other little squares that are kind of yellow. And they're so little, it's kind of hard to even count them. And remember, we're estimating, so some of the numbers we've looked at are probably a little over. So if we added up our 19 red squares and our 9 almost full squares, and the 4 half squares make 2 full squares, when you add them, the area's figure is about 30 miles squared. So if you're looking at a problem like this is what you would do. You'd look for all the holes and kind of estimate from there. Remember, with estimating, you can kind of be approximate or close. So this would be acceptable. Make sure you have down these notes and probably this example so you can see how I came up with this, so that when you have to do it, you have a good example to work off. Okay, so here's 3 shapes, and I want you to find the answer to them. And remember, we're looking for squared units. So you can put the number units, since we don't have an actual label, units squared. Okay, you can just write it like that for each one. Blank units squared. Blank units squared. All right, good luck. Come back when you're done. So here are the answers I got for 1, 2, and 3. For number 1, I got 8.5, and as you can see, all the unfilled squares were all halves, so it was really easy to kind of count it up. There were 3 of them, so that had to give us a half left over somewhere, and I got 8.5. For number 9, this one took a little bit more, but I rounded off to be about 9 here. I had 1, 2, 3, 4, 5, 6 full squares, 7, and that one kind of does another, that's kind of 2 halves, right? 7, that's about another half, and that's about another half, so I got about 9 there. You might have had a number close. If you have a number close to it, give yourself credit. And then for the heart, we had 4 full squares, and then all the little ones around the outside made about 2. So those are the answers I received. Again, if yours is somewhat close, give yourself credit. All right, so we got a really easy example in. Now let's start to look at some more specific shapes that we can really do a little easier than just having to count squares up. All right, here's where our formulas are going to start to pile up on us. And again, like I said, having a page in your notes where you can have all these listed along in your notes for each lesson will make it really easy. And if I make you write it twice, that just gives you additional practice to remember what you're writing down. So the first thing we're going to talk about are rectangles. Rectangles or squares, they kind of use the same process. So to find the area of a rectangle, all you have to do is multiply the length by the width. So all you have to do is really know this formula. A, which stands for area, equals L times W. Remember, if there's nothing in between the letters, it means to multiply. So if we look at our example here, this is 12 square units. Yes, you could count up all the red squares, but you could also just look at how long it is, which is 1, 2, 3 long, and it's 4 long up and down, and 3 width. So 4 times 3 would give you 12. So this is 12 square units. Make sure you have this definition written down before moving on. All right, so let's get into some practice with using this formula. This formula is one of those plug and chug kind of things. All you have to do once you have the formula is look for the parts that match what the letters represent. So if we look at our shape here, it's a rectangle, and it's 15 length, 9 width. I guess it doesn't matter. 9 could be your length and 15 could be your width if you want. But the first step should always be to write the formula. So A equals L times W. One thing that does is it reminds you what you're doing, and it reminds me when you're taking quizzes and tests and doing your homework that you know what formula you're using. The second step is you substitute the numbers in for the letters. So the length was 15 and the width was 9. So go ahead and put 9 in for W and 15 in for length, and then all you got to do is some multiplication. Use a calculator, you find that 15 times 9 is 135. So A equals 135 inches squared, and that's how you come up with that. So go ahead and write that down in your notebook so you have a good example to work off. And here are your three rectangles that you're going to work with. Remember, the first step for all these should be A equals LW, A equals LW, A equals LW. Then after that, you're going to replace the letters with the numbers. Oops, I don't want to write L again. Blank times blank, and area equals blank times blank. And then finally, area equals blank, and this is millimeters squared. Area equals blank inches squared. Area equals blank centimeters squared. Go ahead and write all these things down I did in green along with your answers. Come back when you're done. And these are the answers you should have received. Now your numbers in the second step might be in a different order, but it shouldn't matter. You should still get 98, 101 and 1/10, and 24. I'll make that look more like a 2. 24. If you got these all right, come on over and give me a high five. You're right on track for understanding this stuff really well. All right, so we got the rectangle part out of the way. Sometimes you'll see these rectangles that look like someone leaned on it and made it bend over. We call those parallelograms, but I like to think some big giant put its arm up on it and leaned over. Dorky, yes, but do you expect anything else from me? Probably not. All right, so let's say we have to find the area of a parallelogram. Well, the formula for a parallelogram is the same formula as a rectangle or square. Area equals BH. The only difference is BH is replaced by LW. B stands for base, and H stands for height. Okay? The base is the number at the bottom, and the height. Remember, you can't measure this this side of the slanted side. So what we do is we try to go from one point at the top all the way down, and we measure that out to be the height. So in this example, we have 1 1/4 and 2 1/2. So the first step will still be to write the formula, A equals BH. The second step is to substitute the B and the H for numbers. So you could write all this or just write plug and chug the numbers. So we have 2 1/2 times 1 1/4. Now you can use your calculator to figure it out, but also remember when you're working with fractions and they're mixed numbers, you multiply the denominator by the whole number, and then you add the numerator. Your denominator stays the same, your numerator is the new number. 2 times 2 is 4, plus 1 is 5 halves. 4 times 1 is 4, plus 1 is 5 fourths. And now from here, you just have to multiply the numerators. 5 times 5 is 25, and 2 times 4 is 8. And to turn that back into an improper fraction, we just divide 8 into 25. 8 goes into 25 3 times with a remainder of 1 over 8. So the area of this parallelogram is 3 1/8 feet. And that's how you get the answer. Just plug and chug the numbers that match the letters, and you get your answer. Write this down before moving on. And again, it's your turn. So remember, the first step for all these is you write the formula, A equals BH. A equals base times height. A equals BH. The second step is A equals, and now you replace the letters with the numbers. You're plugging and chugging, and you're plugging and chugging. And then just remember, you write area equals with the answer, and the first one, it's feet squared. For number 8 here, it's area equals blank centimeters squared. And the third one is area equals blank inches squared. Plug and chug, come back when you're done, and make sure it looks and follows the 3 steps that I show you here. And here are the answers to questions 7, 8, and 9. Now, with these, it did actually matter where the base came from and where the height came from. It probably didn't matter in the process of multiplying because we know with multiplying, it doesn't matter which order they're in. The factors can be switched and you still get the right answer. But anyways, these are the answers you should have received. If you did, give yourself a pat on the back. All right, here's your box of thought. Give me some good responses to these, and then you can move on to your quiz. And here is your quiz. Now, with 3 and 4, I would encourage you to draw out the shapes before working on them. And number 4 is a little tricky. It's actually asking for a shape that might have a shape inside it that you have to subtract. It's going to be a two-step process. We'll see how well you do with that one. Don't forget to label them. Plug and chug. You'll do great. All right, that's it.